Okay, so, and again, when I do the review sessions for final exams, I just do the new material stuff because the cumulative, those hints are the same hints from the previous review sheets. So, and you have the exams, you know what the answers are and stuff. So I feel like the newer stuff is actually the more critical. Okay, so, and I said, I tend to turn those bullet points into like numbers just because it's easier for me to be like 1, 2, 3, whatever. So, okay, so that first one, consequence of running multiple t-tests with more than 2 levels of the independent variable. Basically, know what happens to the type 1 error rate. I mean, that's essentially what's the problem with doing it. Let's see, number 2, the F ratio is, well, know what's in the numerator or what's in the denominator in terms of the variance that's being compared. Let's see, 3, interpreting the F ratio. This is one of those questions that's got 2 blanks in it. And it describes the between groups variance being, say, larger relative to the within groups variance. What does that tell you about the distance between the sample means? And what does it tell you about, say, the likelihood of rejecting the null? Let's see. Number 4, choosing the correct ANOVA. So this one's going to give you a bunch of options that describe like an experiment and wants to know which of them you would use a between groups ANOVA for.
Is that like all the extra credit we've been doing? Decide the test or whatever?
Gosh.
So it's got like that graph on it.
This one just has like in words describing, okay, they want to look at this, you know, and it will describe sort of what the variables are like and like how many levels you have.
Okay.
And how they collected the data.
Okay.
So based on that, which one of those would be a matchup with the between groups?
Okay.
So yeah, I do actually end up getting several questions sort of throughout this that are related to chapter 18 stuff with choosing the correct test sort of thing. Yeah. Let's see. 5, how can homoscedasticity be tested? This was kind of like that quick and dirty way of comparing the largest variance, so the group with the largest variance, how big that variance is, to the smallest variance. And as long as the smallest isn't more than twice the size of the largest, you're okay. Okay, so 6 is, what does a significant F statistic mean? So the F tests all of the groups at once. Well, if it's significant, it's more like what it doesn't tell you.
Okay.
Which would be exactly which of those are different from each other.
Yeah.
So that's kind of the idea of the question.
Okay.
So, let's see, 7, given degrees of freedom and a calculated F statistic, make a decision. So for this one, you'll have to use the table to find what the cutoff is,
Okay.
and then determine whether or not that the calculated F that they give you is past the cutoff or not.
Okay.
If it's past the cutoff, you can reject. If it's not, you fail to reject. Let's see. What does eta squared represent? I mean, this is kind of like a definition of eta squared.
Okay.
I mean, as far as what it is.
Yeah.
And it has to do with the variability that's accounted for.
Okay.
19. When are post hoc tests used? Well, you got to use a post hoc if you reject a null that has more than 2 means. So, 10. How is the Bonferroni test used? Which, of course, is a post hoc. That's the one that basically what you do is you take the type 1 error, so 0.05, and then you divide it by how many pairs of means you're looking at, and that becomes the new p-value you have to get to.
Okay.
So it essentially makes it harder to reject a null because instead of having to be less than 0.05, it's got to be less than something even smaller.
Okay.
Okay. 11. Assumptions of ANOVA. Okay, this is one of those questions that basically is wanting to know which one is not an assumption of ANOVA. So as long as you know what the assumptions for the ANOVA are, should be in good shape. Let's see, 12. A repeated measures ANOVA is also referred to as, and that's your within groups.
Okay.
So, because you're measuring the same ones over and over. So, within groups or repeated measures.
Hi, this evening we have the wonderful Carl Fritz, now Brady, doing some breathing movement and affirmations yoga in the C-Towel, which is down here on the first floor, just past the printer. This session is about 10 minutes and it's breathe work and gentle movement to balance the hemispheres of the brain. This bite-sized session will use alternate nostrils breathing to practice calm the nervous system. This breathing technique is great for
It actually does work very well.
Sit down to concentrate. We will combine the breathe work with gentle stretches. We have yoga mats and all the things that you need, so make your way over to the C-Towel. If you don't know where that is, check with the circulation desk.
Okay. Yeah, they did that when I was recording for the other review session. Only it was like they were doing a drawing.
Oh, yeah.
Okay. Fun stuff. All right, where were we at? 13, I think. When to use a paired t-test versus within groups ANOVA. And it's got 2 blanks, so basically, how many groups do you have when you're using the paired t-test? And if you remember the t-test 2, right? The ANOVA is going to be more than that.
Okay.
Let's see. Let's see, 14. Between versus within groups designs. Which one of those does a good job of reducing variability that has to do with individual differences?
Is that the between? I don't.
Well,
Back and forth
between means that you have different participants in each of your conditions. So if you've got 3 groups, you've got, and let's say 10 in each, you've got 30 individuals, and they're all different.
Okay.
If it's within groups, same sort of setup, I've got 10 that I run through all 3.
Okay.
So there's only 10 people you have to worry about individual differences
Okay.
for.
That makes sense.
And that's part of one of the why it's a more powerful test.
Okay.
Because it allows you to account for a certain amount of the variability that would normally get tossed into the denominator, the within group stuff. You get to pull some of that out, and it makes that smaller.
Okay.
So you get bigger F's.
Yeah.
Let's see. 15, order effects and ANOVA. So again, still in the realm of the within groups, ANOVA at this point. And when we talk about order effects, that's essentially going to be an additional assumption that needs to be looked at.
Okay.
Because if you do run your participants through condition 1, 2, and then 3 all in the same order, and you see changes, you don't know if it's due to just the order that they were put through or if your manipulation works.
Okay.
So you want to be aware of order effects, and if you can jumble up the order they go through for the different participants, then you can argue that's not a potential alternative explanation.
Okay. Yeah.
Yeah. Let's see. 16, finding cutoffs for F using the correct degrees of freedom values. And by that, I was trying to emphasize the fact that with the within groups ANOVA, we have one additional line of information about the subject's source information. But the thing is that the degrees of freedom associated with that, we can calculate an F, but it's not a meaningful F.
Okay.
So if you want to find the correct cutoff, you want to use the between groups degrees of freedom and the within groups degrees of freedom. You ignore subjects. So the question basically gives you listing off all of the degrees of freedom.
Oh.
And you need to make sure that you select the between groups and the within groups to take to the table.
Okay.
Otherwise, you'll end up with the wrong number.
Yeah. No. Not wanted.
Nope, we don't like wrong numbers. And then 17, given a source table, calculate the F of interest. Again, which of the mean squares should you be dividing out here? Just ignore the subjects line, because like I said, that nobody cares about that. It's between versus within.
Okay.
18, given a source table, calculate the F of interest and make a decision. So this one has you take an additional step here. So again, ignore the line that says subjects.
Okay.
Figure out the F. But then you're going to have to take the between degrees of freedom and the within degrees of freedom to the table and find the cutoff, so that you can decide whether to reject or fail to reject. So that's going to be a two-step kind of question. C19, what are weird samples? Basically, if you know what weird stands for, that's the answer that you're going for. Okay. With a within groups ANOVA, relationship between variability due to individual differences and the size of the F statistic. And this is another one that's got two blanks in it. First off, the variability, that within variability, the stuff between the subjects. With the within, because you have fewer subjects, it goes down, right?
Yeah.
And because of that, what's in the denominator gets smaller, so when you divide it, you get a bigger F.
Okay.
So that's essentially what the question is getting at. It's just got two blanks in here for the correct term. Let's see. Okay, so 21, advantage of a two-way ANOVA over two separate one-way ANOVAs. Well, I mean, basically with the two-way ANOVA, you can see whether or not one variable has an effect on the other one.
Okay.
So you can't see that with separate ANOVAs because you're just looking at one independent variable at a time. Let's see, 22, the combined effects of two independent variables on a dependent variable is, well, essentially what they're talking about there is an interaction.
Okay.
Okay. Let's see. 23, given a description of a study, describe the design. Okay, so it's going to basically tell you what they're looking at in terms of variables. So how many variables. They're also going to tell you how many levels for each. And then it wants you to basically, okay, using the notation, how would you label this ANOVA, okay? So again, the number of independent variables is the number of numbers that you see, okay? The number itself is how many levels of that independent variable.
Okay.
So, and then the other part of it that's going to be important to keep in mind is it within groups or is it between groups?
Okay.
So, which will be described in the little description here.
I gotta say.
Okay, let's see. 24. Given a source table, calculate the F statistic identified. So it's going to ask you for a specific F statistic, because with the factorial ANOVA, you've got each independent variable is a source, and then you have the interaction, and you have within. So it's going to ask you for essentially one of the sources. Okay, and so depending on what that is, you get the mean square and calculate the F. Okay. Let's see, 25. A mixed design includes. Of course, the mixed design means one of my independent variables is being measured between groups. The other one is being measured within groups. Okay. So it's a mixed design.
Yeah.
Let's see, 26. How many null hypotheses are evaluated in a two-way ANOVA? Well, a two-way ANOVA means I've got two independent variables. So I have a null hypothesis test for the first variable. I have one for the second. And then I have a third null for the interaction between the two.
Okay.
So there's three for it. Yeah. 27. Measure of effect size for two-way ANOVA. Well, that's where eta squared comes back. Yeah. 28. Direction of correlation described. So it's gonna basically tell you variable one is doing this, the second variable is doing this. Is it a positive relationship that's being described? Is it negative? Okay. So if they're both going up, it's positive. If one goes up as the other one's going down, it's a negative. Let's see. 29. Compare two correlation coefficients. So it's basically going to give you these two correlation. In fact, this is, I think when I was talking about correlations and what the correlation means, I mentioned in class that there would be a question on the exam like this. But essentially, the sign out in front, all that tells you is it positive or is it negative? That's all it tells you. The value of the number tells you how strong it is.
Okay.
And the closer that is to 1 or -1, the stronger it is.
Okay.
So this is going to give you a couple of correlation coefficients. It's going to ask you something about, well, strength.
Okay.
So when it asks about strength, ignore the sign out front.
Okay.
Okay? Because that has nothing to do with the size of it.
Okay.
Let's see, 30. Primary limitation of the correlation coefficient. Well, sort of its big shortcoming is cause and effect.
Okay.
Okay? I can't establish cause and effect with just correlation.
Yeah.
Doesn't quite get me there. Let's see, 31. Test retest reliability measures. Well, basically, when you're doing test retest, you're measuring with that instrument now in a week, so you can see what happens over time with it if it's reliable.
Okay.
So. Let's see, 32, correlation coefficient range. So what are the values run between?
Okay.
-1 and +1, right?
Yeah.
Let's see, 33, what conclusion can be drawn given a correlation coefficient and cutoff? And it's about how it sounds. It's going to give you a Pearson's correlation coefficient that was calculated, and it's going to tell you what the critical value is, what the cutoff is.
Okay.
And essentially, it works the same way as like with an F.
Okay.
If the correlation coefficient is bigger than the cutoff, i.e. it's got a stronger correlation, it's significant.
Okay.
If it's not, it's not. And the way that we sort of talk about that with correlation is if it's not past the cutoff, then we basically say that there's not a significant relationship between the variables. See, 34. Psychometrics use correlations to examine, well, the two main things that we use those correlations for, if you're trying to see if a test is worth anything, reliability, validity.
Okay.
So. 35, evaluate correlation coefficient values. Okay, so I put two questions that kind of get at that same idea of how do you tell, which of a set of correlations is, say, the weakest or the strongest, that kind of thing. Um, 36. What should be done before calculating a correlation coefficient? And this is absolutely critical. You have to do a scatter plot first.
Okay.
You have to look at how the data points are dispersed on that thing, because one of the things about the correlation coefficient, if it doesn't look like it's like a line of some sort, correlation coefficient's going to be wrong.
Okay.
Even if there's some other pattern there, it'll be wrong. So you got to look at the data first. Let's see, 37. The null hypothesis when evaluating correlation coefficient. Well, I mean, the null hypothesis, if you're looking at correlation coefficients, would be basically there's no correlation. There's nothing going on. Yeah. Let's see. 38. Reliability versus validity. This is a definition kind of question. So if you know what validity is and what reliability is, yeah, it asks for one of them. Oh, let's see, 39. Given values for a regression equation, calculate the predicted y. Okay, so this will be where you're going to have to, it gives you what the values are, but it doesn't put them in the equation for a line.
Okay.
So you're going to have to know where those numbers go in the equation, so that then you can put whatever they give you for x into the equation and solve it.
Okay.
So let's see. 40. Appearance of scatterplot as it relates to standard error of the estimate. Well, basically the standard error of the estimate is kind of like the variability around a regression line.
Okay.
So if on the scatter plot the data points are really close to the regression line, then that's going to be smaller error.
So I just got like screwed in it every semester.
Okay. Let's see. 41. Difference between simple linear regression and multiple regression. Well, simple linear, you have one predictor. You have just the one x.
Yeah.
Multiple regression, you have multiple predictors.
That was pretty simple.
Yeah, that was pretty straightforward. Let's see, 42, regression versus correlation. And this is one of those ones that's got two blanks. But basically, what is regression used for? What is correlation used for?
Okay.
I think that was one of the very first slides, I think, for the regression chapter.
Okay.
In fact, it's probably almost stated almost the same way, I would think. Let's see, 43. Regression to the mean this is pretty much a definition.
Okay.
So if you look up what that definition it is, and so you know what that is. 44. How does a regression line differ from all other possible lines through a set of data? Well, the regression line is also the line of best fit. It's the one that has the least amount of error.
Okay.
So the dots on the scatter plot are as close to the line as they could possibly get.
Okay.
Any other line, and you're going to have one or more of them that's going to be farther away. Let's see. 45. What does the proportionate reduction in error measure? That's kind of a definition too.
Okay.
So see, 46, given a table of multiple regression output, identify the value indicated. So I think it was the last slide in the regression chapter set of slides where I show that like SPSS output, that table, and it has pointed out what the different numbers in the table represent.
Oh, okay.
So this one is going to ask you about a particular value that's in there.
Okay.
So make sure you know which number is the y-intercept value, which one would be like the coefficient for whichever independent variable or predictor, that kind of thing. Let's see, 47, what does chi-square assess? Well, I mean, basically it's just looking at observed data and whether or not it differs from the expected.
Okay.
You know. Let's see, given information about a chi-square goodness of fit, find the cutoff. So this is going to give you, it's going to tell you how many levels there are for the variable, which means you're going to have to turn that into degrees of freedom so that you can use the table to find what the cutoff is. Let's see, 49. Threshold for significant cell differences based on the adjusted standardized residual. Sort of the rule of thumb there is that if it's larger than 2, then the observed frequency significantly differs from expected.
Okay.
Yeah. Let's see, 50, effect size measure for chi-square. Well, what is that thing called? That's all it's wanting. Katie, what are you doing?
So, first page of each article. I don't think this is what you want.
Yeah, that's fine.
That's
I want to know what the title is. It's got the author's names. It's got where it came from. Yeah, that's what I want.
Okay, I wasn't sure.
Where are we? 51. Danger of reporting just relative risk or relative likelihood. The biggest risk with that is if you don't report the base rate associated with it, it can be really misleading.
Okay.
So it can make something sound a lot scarier, say, than it actually is.
Okay.
Let's see, 52, choosing the appropriate chi-square test to use. And of course, this one's got 2 blanks.
Okay.
We only know about 2 chi-square tests, so as long as you know which one goes with the 1 nominal variable situation, which one goes with the 2 nominal variables, you'll be fine.
Okay.
Oh boy, these are several of these are sort of in the same vein. 53, identify the correct statistic to use. It's going to give you an idea of what kind of outcome variable you have and what kind of, say, independent variable you have, how many levels there are, and how the participants are measured.
Okay.
And it's going to ask you, okay, what's the right test?
Okay.
Let's see. 54. Given a study description, identify the correct statistic to use. This one's a little bit longer
Okay.
because they actually, instead of just giving you general information, it's like, so-and-so is looking at the relationship between this and this, and,
Okay.
so yeah. Again, pay attention to how many variables of what type they've got, and then go from there. Let's see, 55. Given a study description, identify the correct statistic. This one's a bit more like that previous one.
Okay.
So it'll actually give you an actual description of things that are being looked at. How would you do it? 56. Identify section of a research report containing the information described. So this is where you might want to make sure that you've got a handle on what shows up in the introduction, what kinds of things show up in the method section, what kinds of things show up in the results, what kinds of things are in the discussion, and it is going to basically tell you, okay, this is this information, which section is it going to be in?
Okay.
So be sure to refresh your memory on what things show up in those.
Yeah, that's in the last.
That's chapter 18.
It's got the whole chart. Yeah.
Mm-hmm.
The little
Yeah, and then describes, okay, this is the kind of thing you're going to find.
Okay.
So, if you're looking for the hypothesis, where would that be? If you're looking for the statistical analysis that was conducted, what section would that be in?
Okay.
Yeah. Let's see. Let's see. 57. Additional statistics that APA encourages researchers to include. So it's going to give you a bunch of options, and the main thing to remember is that if possible, you should also include confidence intervals and effect sizes. Okay? 58. Go figure. Given a study description, identify the correct statistic to use. Again, it's going to describe to you what they're looking at and how they went about doing it. And then you come up with, okay, this is the analysis.
Okay.
59. What are the 4 major parts of a traditional research paper? So it's going to give you the abbreviation IMRAD,
Okay.
and it's going to ask you for what one of those letters stands for.
Oh, okay.
So if you know introduction, method, result, discussion, you're fine. And then the last one, identify section of research paper containing the information described. So again, sort of a rinse and repeat.
Okay.
Okay, so that